kan gewoon beginnen wanneer het je uitkomt.
Okay, welcome. I want to tell today something about behavior-based robotics, and we will cover the first chapter, what tells about the history of robotics. And although this is already an old book, and the history of robotics is not that old, we will see that some of the origins are from much further ahead, even back to the Greek history. What I want to teach you today is that you have some idea what not only what robots are, but also what intelligent behavior in robots is, and appreciate how we came so far with the current level with intelligent robots. So, if you ask the Robot Industry Association what's the definition of a robot, they have the good old-fashioned reprogrammable multifunctional manipulator, what you often see in the factory. And that's good enough, and that's also the most common version of the robot as used commonly in the world. And that has already quite an old history. If we go back to the Greek, we see that the Greek already had a lot of automata, so things to automate their work. But they didn't like to really get those things to work. They saw it more as something mystical to in their different temples to see what's going on. So one of the uses they had was simple water clocks, where you fill in a basin with water and let it drip, and that means that you have a sense of time. And even now in the most churches, the clock on the tower was one of the main means to automate the whole society. That was already in use in Greek history. But they used that same mechanism of both water and wind power to also actuate things. One of the examples is that they used a windmill, not so much to what we would do in the Netherlands to level up the water, but to pipe automatically an organ so that you have nicely music inside your temple. And when you do that, you want to have a different sort of music, and that is also what it covered later, because making music and waving is originating from the same origin. During the Industrial Revolution, a lot of water power was used to starting to loom and to make fabric, but you want that your customers every time have a different sort of fabric, so they started to create looms that you could program, and they learned it by getting programs in search of dots working. And that sort of automation of the looms, that was later on used in the Ford assembly lines, where people all get their tasks and starting to assembly cars. That was all human labor, but in 1961 the first robots arrived along those production lines to do the labor. And nice thing, if you see on history, this was after the Second World War, and that meant that during that time a lot of American soldiers died in Europe in the Second World War, and there was a shortage of production workforce, and that means that the different industries start to think how to could automate, because otherwise the power of the workers' union become too strong. So that's a common theme. Industrial robots are made to replace human workers, and that's a great thing for tasks that are highly repetitive, well structured, as the work along the assembly line in factories. But that's only, say, part of the robots as we know. The name robot was introduced in 1920 in Czechia, and that's in a screenplay. And both the time and the place are important, because 1920 was precisely behind the Russian Revolution, but also the place in Czechoslovakia. That's the end of the Habsburger Empire, and you have still a lot of nobility, and they saw what happened with the nobility in Russia, and they were quite afraid that the labor force would get also in revolution in the western part of Europe. So they made a screenplay where they introduced mechanical mans that would replace the workers, and already in the first time that the name robot was introduced, directly you had a robot revolution where the robots killed whole humankind. Was that because the robots were evil? No, because the men were evil and decided that you can use robots not only in the factory, but also give them guns to fight against other countries, and that resulted in that robots killed whole humanity. On the other side, Capek was really a visionary, so he thought already about this scenario, and he made sure that the humankind was in control of the robots. So there was only one place in the world where a robot could be made. There was the blueprint, and he kept that safe. But when humankind was exterminated, the robots went to that island to pick up the blueprint, and the last humans burned that blueprint and killed thereby the robot race. So that were optimistic times directly after the First World War. But it is not only Walt Disney and Hollywood that have thought about killer robots. So in that sense, the robot is an artificial worker that can replace a human worker in the whole sense. So it has to replace a human both in body and in mind. And we work with that concept already for a long time in our artificial intelligence, and there we see that we're able to replace the human knowledge and the human rationale quite well, but to make really good AI, that we also have to find a replication of human perception and human actuators and human communication. So we try to build a robot with the brain and the body of a human, and that's already done since ages. If we go back again to the Greeks, in this case Crete, we saw that they thought about a big bronze metal human, not a human but an automaton, that made sure that Crete stayed safe from all the pirates that were running along the shores. So that robot flight 3 times a day along the coastline of Crete, and every invader or every pirate that it saw, he attacked, and so it became the real first defense force. So currently our Dutch defense company, where I also have worked for, with it, has branded that name. But that was still, say, science fiction from the Greek. Later on, really people start to make automata that really looked like human. For instance, in the Arabic Empire, you had they not only invented mathematics, but you also had Al-Jazari, and he made a complete boat floating in the lake, and that was filled with automata in the form from humans, and those automata were able to play each a different instrument and made quite some lovely music. Now, after the Reformation, also Europe started to play its role. Leonardo da Vinci not only thought about the first flying machine, but he also thought about an automata in the form of a human, and he borrowed one of the armors of one of the knights, and he built a whole mechanism with different levers in it, so that it could move its arms quite natural. To make it really natural, Jacques de Vaucanson made also very nice automata. A part of them, they were playing music again, like before. We will see that more often. But they were also really alive. And one of the biggest examples was the duck that you could feed some grains, and when you give it some grains, some differentiation with it came out of its back, and that was real differentiation. Only you had a big barrel under in the statue, and the fermentation that took weeks with it to really differentiate the grain. The nice thing, the link, is that the Jacques de Vaucanson worked again together with the people that were programming the loom. Another big example where still the replica is visible in the museum from computer science in Paderborn is the chess-playing Turk, where they were able to pick up pieces and place that correctly on the board. Actually, they made a tour along the different rulers of Europe. One of them was Napoleon, and Napoleon was a big, one of the biggest generals ever. But Wolfgang von Kempelen, that made this chess-playing Turk, was able to defeat Napoleon by chess. He did it partly by cheating. There was actually a human hidden in a cabinet, but it was really a small one. And from mechanically, it was quite a masterpiece, because the human inside the cabinet was able, via small light tubes, seeing what was happening on top in the board, and with levers was able to manipulate the Turk. So we move into this century, and one of the nicest examples is Electro. Electro was built before the Second World War in 1939, and was made purely analog. So no computers yet. Those were invented on the end of the Second World War, but still they were able to do voice recognition with this robot. So I will show a YouTube video here. That works. No, that doesn't work. So I will provide the link, and you can with it look that up. Okay, so robots that are built in human shape. The most important, the most easy thing is to have a rowboat and let him drift. But at a certain moment you have to start to make him walk. If I go back one slide, the Washington House motorman had legs, but under his feet there were some roller skates where he could move forward and backward. In Japan, they had a whole program to start to make humanoid robots with actually moving with the legs. They started at the University with some prototypes that could walk straight. But 10 years later, they had already the Wabot 2, which had not only had functional legs, but also functional arms, and was able to play piano. As you see, playing instruments for robots is really fun, and still now you can find a lot of movies of robots playing the trumpets, etc. Because we're looking at history, you also have to see how big the head of the Wabot 2 is. That was a video camera in that time, and you need a full-size head for what we currently have in our telephone. And actually with it, the resolution was far worse than what you currently have in your telephone. So you see the improvement that we made in the last 40 years. That sort of robots, they were not only provided inside the university, but they also started to work together with the different companies that did the automation in the factories. So they had a free walking with a robot Wasida Hatishi leg, and on the end that ended up in the two-legged robots, the Curio, that was made by Sony. Also Honda had its own program, the Asimo, and as you see on the left, they started with just a prototype like the Wasida with just some moving legs. You also see how big the boxes were in the beginning, and that was to have enough computing power on it. And once they packed the limit, they're starting to reduce the size again, and that is really helpful because if you have a bigger robot, you can make it far more dynamically, and you can also easily fall and walk much harder. In Japan, they really like to make robots in human shape. One of the biggest program is in Professor Ishiguro's lab, and he made a whole series of different Geminoids. One of them was his daughter, and when his daughter came into the lab, she was really scared that there was a living, breathing copy of herself in the lab. But he also made a copy of himself and a copy of one of the main presenters. And he put a lot of effort to make that lively. And a lot of effort goes in realistically get all the movements along the eyes and in the face, so that you really start believing that you're talking with a human. And currently the level is that if you are introduced to the robot for 20, 30, 40 seconds, you believe that you're talking with a real human instead of a robot. So I want to end here what is all done to get robots in the shape of a human. And we move into another branch of robotics where they try to get robots in the form of, you will see in the human kingdom, that you build robots that show natural behavior. And part of that natural behavior is a predecessor of artificial intelligence, the Cybernetics, where they made mechanisms and mainly purely automatic with analog control. And what you see is that the Cybernetics was the marriage of control theory, information, science, and biology. And why was control theory at that moment starting to get important? Partly that was, again, the Second World War, where they found out that the fighter pilots, the rockets, they all moved so fast that humans could not longer control what was going on, and you needed automatically control to follow such a rocket. And it means that the human went out of the loop, and all the control were given to Automata, and you have to do that fast. At the same time, you also saw that the information flows get more and more with it complex. But that was already known from biology, where also they made system theory, that sort of information flow through living features. So bio-inspired, they started to look what sort of behaviors automata could show. And the one that really pioneered the big name in cybernetics was Norbert Wiener. And in 1994, he started with creating a mod. It was a small robot on wheels, 3 wheels, and he had a number of photocells. They were on the front, and he was attracted by light. And if you move such a robot through the corridor, you see the path through it, and you have really natural behavior. Later on, the Mechanica Speculatrix was made. That was not longer a mod, but a tortoise. Still an analog device, but now it not only had 2 sensors, but also 2 nerve cells. And they started to make, with such a simple combination, already quite some complex behavior. So they showed on this level already with it different complexity in behavior. So first, the parsimony. So that means that by combining some simple reflexes together, you get some emerging behavior that is far more complex. The other thing, what really makes this Mechanica Speculatrix really natural, that it would just never stand still. So you have the feeling that it was exploring the environment. With the sensor, it was sometimes attracted to certain parts, and also afraid of certain parts. And by tuning that, you could train the robot to distinguish between productive and unpredictive behavior. So, what sort of behaviors that tortoise already showed? It was looking for lights. It headed toward weak light, but if the light became too bright, it was afraid of it, and it turned back. It could turn and push, so with the weak lights, when it was attracted to it, it could bring forward. And it could find its own battery charger by with it going to the light. The most famous, where everybody thinks that this sort of robots are made, are Braitenberg vehicles. But Braitenberg from psychology, and he only made this sort of vehicles as thought experiment. But he was able to, with a combination of a few simple sensors and a simple wiring between the sensors and the actuators, to show quite complex behaviors. He made more than 12 behaviors on it. And, but he all did that in as a thought experiment. As roboticists, we like that idea too much. So in America, in MIT, they actually used some Lego bricks to implement most of those Braitenberg vehicles with Lego Mindstorm. And they created 12 of those behaviors. 6 are really simple creatures with names as timid, insensitive, paranoid, dogged. But some of them were also quite complex as the consistent behaviors. And some they even called philosophically the observant creature. Okay, but that's all fixed wiring of the sensors and the behavior. And in good old artificial intelligence, you want to have some reasoning in between. And it means that you are starting to reason based on the knowledge that you have. And in robotics, you have some quite nice examples of what's possible with a robot if you start to using your knowledge and to start reasoning with it. And we will walk one by one to some of those most nice examples. What you see in the beginning, artificial intelligence was tightly coupled with cybernetics, and they all had the same common ground as representation, memory, reality, and epistemology. But each of them had a slightly different way of how it was implemented. And we will see that part of those how they implemented are the hallmarks of behavior-based robotics, and that's precisely why this book is that good. So what you see is that the robot is not in a virtual world, but in the real world. And it means that you don't have to be that complex, but you can use your sensors to get a representation of the world. And because it has an embodiment, that means also that behaviors change where it is, but also, say, the rewards of surviving or going to the right place is quite natural to give. And the intelligence, you always can ask where is a robot really intelligent? At the moment that the robot survives in quite a harsh environment by not sitting still and hiding, is the more philosophical Braitenberg vehicles. But really interacting with it, you have the feeling that intelligence is emerging from it. Okay, what are those early AI robots? So the first one, as covered in the book, was Shaky. I also have a robot called Shaky, and he has a really shaky head. So I think that the first robot of CMU named Shaky has that same behavior. And in that time, it was able to do visual navigation in a real world. What was special on that world? It was a complete black and white world. So it was running on a white floor with black stripes along the wall, so that you always know for sure where the walls are. And also all the objects that it could pick up where it's clearly visible with stripes so that you can easily recognize the edges. So it had both vision and contact sensors. The vision that you see is the big black box that is looking up. It looks to a mirror, and in the mirror you can look all around. So the other thing, what's special about this robot is the box that's in below. That are actually two computers because the computer power was not enough to process it all on one computer. So one of them was to get the images from the camera, and the other one was to do the planning. So more of those examples are found, for instance, at Hilaar. Hilaar was a robot that was not that high, only 1 meter high. And it had quite a complete sensor suite from both video, ultrasound, and laser rangefinders on it. It worked for 10 years, but it had a weight of more than 200 kilo to get all those equipment around. At CMU, at Stanford, they worked also with lighter robots. This is a robot that has bicycle wheels, so it could really go easily over obstacles. It had already stereo vision on board, so it could estimate distances. But to process both images from the left and the right eye, that took over more than 15 minutes. So every time that it knew where to go, then it performed the next step. So it was really quite a light but a very slow robot. The one that really started to work quite well was the CMU rover, what was so successful that was predecessor of many other CMU robots. And the camera was already that small that it could do pan tilt, so that it could look around and can search for objects. So, based on this predecessor, the development suddenly starting to go really fast. One of those robots that really was already quite capable was the robot Dante. That was a robot more or less in shape of a spider. But actually it more tiptoed by putting each leg straight up and straight down. It was a robot that was a predecessor of many of the space robots, and it was the first one that went to Antarctica and actually went down into one of the craters and did the same job as the current, say, explorers at Mars are all doing. The nice detail is NASA asked to look for the bottom of the crater. The robot was really successful in that, but tried to get out of the crater after its job done. But then you have gravity working against you, so it was not able to get out of the crater. It had a teeter going to the back of the robot. So they sent in a helicopter and flew the robot out of the crater by helicopter, something that cannot be done, cannot be saved when you are on Mars. But unfortunately, the teeter broke precisely when the robot was out of the crater, so he dropped back to the floor of the crater, and that was the end of this first successful exploration of the bottom of a crater. He really hit it hard. So, other CMU robots that I encountered a lot are the robot dogs. That was one of the first team that participated in RoboCup, and I encountered them there quite often. Other CMU robots that quite make a dent is the the tartan. We have different challenges from the military, the American Military Research Association, the DARPA. They first wanted to run a challenge in the desert, and after that they did a challenge inside an urban area, and that was also the origin from the Google car, because that was one of the competitors against the CMU Tartan. So that was the origin of all the self-driving cars. DARPA continued with this sort of challenges, but it said in principle self-driving cars is now a solved issue. The CMU continued and went from driving cars to rescuing people from burning houses. So they made a chimp-like robot where they could grow up to stairs, open doors, etc. But we'll see later on chimp-sized robots in behavior-based robotics, but it's covered in one of the later chapters. What I wanted to cover now was that you get an understanding what type of robots there are around, how intelligence you could get into the robots, and how a small view of the history that led to the current state of the art of autonomous robot systems. So, thank you for your attention, and if you have questions, you can put them as comments inside under this video.